Hello friends, in this video we will see questions from refrigeration and air conditioning RAC for your TSPSC AE GENCO to be conducted on December 17th. From RAC refrigeration and air conditioning you can expect one or two questions minimum. So if you solve these 100 questions, definitely you are going to answer those two questions without any doubt. Nusselt number is given by, what is this? HL by K. H is the coefficient of heat transfer coefficient, L is the length of the surface, and K is the thermal conductivity. In case of sensible heating of air, the coil efficiency is given by 1 minus BPF. BPF is the bypass factor. Bypass factor. The undesirable property of a refrigerant is, what is this? High boiling point. It should have low boiling point so that after receiving the latent heat, it will boil very easily at less temperature. The desirable property of a refrigerant is, it should be all of these, that is low boiling point, high critical temperature, high latent heat of evaporation, so that it will boil at low temperature and it will take lot of heat so that very high cooling is achieved. The operating pressure for refrigerating units using R12 as a refrigerant. This is a good question, friends. It is 8 bar. 1 bar is equal to 10 to the power 5 Newton per meter square or 100 kilopascals. Cooling water is required for the following equipment in ammonia absorption plant, where condenser, absorber and separator, rectifier. All these three need cooling water. Whereas in case of vapor compression refrigeration plant, only in condenser water is required. The coefficient of performance of a domestic refrigerator is dash as compared to a domestic air conditioner. This is B, less. In aqua ammonia and lithium bromide water absorption refrigeration systems, the refrigerants are respectively ammonia and water, NH3 plus H2O. In order to cool and dehumidify a stream of moist air, it must be passed over the coil at a temperature, which temperature? Which is lower than the dew point temperature of the incoming stream. If it is more than that, what is going to happen, friends? It is a dew is going to be formed, which is undesirable. During heating and dehumidification process, a dry bulb temperature is going to increase or decrease? It is going to increase. It is going to increase during the heating and dehumidification process, because heating means a rise in temperature. Okay, this is how heating and humidification. So this is your chart will be there something. Okay, so heating means dry bulb temperature increases. Dehumidification means specific humidity decreases. So the two characteristics of this process are dry bulb temperature increase and specific humidity decrease. During cooling and dehumidification, dry bulb temperature decreases. It must be decreasing. Yes or no? It must be decreasing. Dry bulb temperature must be decreasing. In a domestic vapor compression refrigerator, the refrigerant commonly used is R12. It is also known as refrigerant 12 or Freon 12. All these refrigerants are chlorofluorocarbons. There will be fluorine atoms, carbon atoms and chlorine atoms in any refrigerant. It is also called Freon 12. In refrigerators, the temperature difference between the evaporating refrigerant and the medium being cooled should be, how it should be? As low as possible, around 3 to 11 degrees centigrade. Right. This is a good question, friends. Please remember that. The minimum temperature to which water can be cooled in a cooling tower is, this is once again a good question, friends. cooling towers are used in thermal power plants, okay, to cool the water. So what is the answer? The answer for this is B. Wet bulb temperature of the air. There are three temperatures, friends, for air: dry bulb temperature, wet bulb temperature, and dew point temperature. Dew point temperature is the temperature at which the water vapor in the air water vapor mixture is going to get condensed if it is cooled below the temperature. If the water vapor and air mixture temperature falls below certain temperature in let us say winter, the water in the this mixture is going to be coming out, condensed out. That is the dew point temperature. What is wet bulb temperature? It is the temperature measured by a thermometer with a wick at its end, bulb, over the bulb, or wet cloth. Air refrigeration cycle is used in where? Gas liquefaction. This is a good question, friends. Gas liquefaction. The value of COP in vapor compression cycle is usually, COP is always more than unity. COP is always more than unity. What is COP? Heat effect, energy effect sort by work input required. Energy effect sort can be used for heating a medium or cooling a medium. If it is cooling, it is called a refrigerator. If it is heating, it is called heat pump. Right. So definitely, so your work input should be less and heat rejected should be more. So definitely, this ratio is going to be always more than 1. Vapor compression cycle. Okay. The specific humidity during cooling and humidification, dehumidification, it should be decreasing. It is dehumidification, means specific humidity W is going to decrease. The suction pipe diameter of refrigerating unit compressor in comparison to delivery side, is it more or less? It should be bigger. It should be bigger. It should be bigger. Why? Yes. In a vapor compression refrigeration system, a throttle valve is used in place of an expander because why? Because the positive work in isentropic expansion of liquid is very small. Right. In a refrigeration system, heat absorbed in comparison to heat rejected is less. Then only COP will be more, friends. Okay. So let us have a diagram for this. Refrigerator. So how our refrigerator will be like this? So it is like this. This is work input. This is Q. This is Q. T1, T2, Q2, Q1. Okay. So Q1 should be always less than Q2. W plus Q1. Q2 is equal to Q1. So your work input will be added to the Q2 and Q1 will be more. This will be delivered to the what you call source, heat source, which is having high temperature compared to the heat sink. The optimum effective temperature for a human comfort, this is a good question, friends. Lower in winter than in summer. An evaporator is also known as, what is this? It is also known as freezing coil, cooling coil, or chilling coil. All of these are the synonyms for cooling. In a refrigeration cycle, the flow of refrigerant is controlled by expansion valve. Expansion valve. So a TS diagram will be like this, friends. So this is your T diagram. This is right. So like this, right? So this is a expansion, evaporation, compression, and condensation. Okay, compressor, condenser, expansion valve, evaporator. Okay, so it is controlled by the expansion valve, because after liquefaction, after refrigerant is cooled, then it is controlled in the expansion valve. Then it will be going to the evaporator, and where it will take the heat from the place to be cooled, and it will get evaporated. Refrigerant will get evaporated. Vapor compression refrigeration is somewhat like this. Is a good question, friends. None of the above. It is neither Carnot cycle nor reverse Carnot cycle, but it is something different. Why? Your Carnot cycle will be like this, right? TS diagram, PV diagram. This is your PV diagram, right? But your vapor compression cycle is something like this. TS diagram, it will be like this. TS diagram, it will be like this, right? What is this? This is Carnot cycle. Okay, reverse Carnot cycle, it will be like this. Reverse Carnot cycle, which is used in compressor, condenser, expansion and evaporation, like this. Okay, so this is your PV diagram for reverse Carnot cycle, sorry, TS diagram for reverse Carnot cycle. But it is something like this, right? So your refrigeration cycle TS diagram will be something like this. It is not same as that, or it will be like this with the similar parameters on x and y axis. It will be something like this, right? 1, 2, 3, 4 TS diagram, right? At lower temperatures and pressures, the latent heat of evaporation of refrigerant at lower temperatures increases. At lower temperatures and pressures, the latent heat of vaporization of a refrigerant. So what is the answer? It is going to increase. At high temperature, it is going to decrease. Okay, something like that we have seen, right? So this will be your, what you call, this will be your TS diagram for a pure substance, right? So this is your latent heat. It is going to decrease as temperature is increasing. This is your T, and pressure is also increasing. With the temperature, pressure is also increasing. P is directly proportional to T. So at lower temperature it will be more, and at a higher temperature it will be less. Because temperature is proportional to pressure, the similar logic holds good. A refrigeration cycle operates between condenser temperature 27 and evaporator temperature minus 23 degrees centigrade. The Carnot coefficient of performance of cycle will be how much? This will be C. How it will be? So minus 23 plus 273, that is 250, and difference between them is 50 degrees centigrade. Yes, right. So your COP will be equal to 250 by difference in temperatures, 27 minus of minus 23, that is plus 23, that is 250 by 50, that is 5. That is 5. The bypass factor in case of a sensible heating of air, where TD1 dry bulb temperature of air entering and heating coil, TD2 dry bulb temperature of air leaving and the heating coil, and TD3 dry bulb temperature of the heating coil. So what is the formula for this particular bypass factor? It is B, TD3 minus TD2 by TD3 minus TD1. Heating coil will be the highest temperature, and TD1, TD2 are the dry bulb temperatures of air entering the heating coil and the leaving the heating coil. So remember this formula. The general rule for rating refrigeration system excepting for CO2 system is to approximate following HP per ton of refrigeration. This is a good question, friends. This is a good question. It will be approximately 1 to 2 HP per ton of refrigeration. 1 to 2 HP, that means what is the amount of, so this is something like this, okay. So this is your this thing, right? This is your this one, T1, T2 is right, Q2, Q1, this is W. W plus Q1 is equal to plus Q1 is equal to Q2, friends. Okay. So for each 1 ton of Q2, what is W required? It is he is asking that. Okay. Per ton of refrigeration, you need 1 to 2 HP per ton of refrigeration. 1 ton is equal to 1 TOR is equal to 3.5 kilowatts. Okay. So you need 2 HP. So 1 HP is equal to approximately 0.75 kilowatts. Okay, that means 0.75 to 1.5 kilowatts per 3.5 kilowatts of heat to be absorbed to cool the space where we want the cooling. The freezing point of R12, this is a good question, friends. Remember this, it is minus 157.7 degrees centigrade. The quotient of performance of a refrigerator working as a heat pump. Okay, so there is a relationship between COP of pump is equal to refrigerator plus 1. Okay, remember this. Heat pump COP is equal to refrigerator COP plus 1. The difference is equal to 1. COP of heat pump minus COP of refrigerator is equal to 1. During a refrigeration cycle, heat is rejected by the refrigerant in where? Condenser. Just now I have given TS diagram, friends. Freon group of refrigerants are, so what are the characteristics of freon group of refrigerants? They are non-toxic and non-inflammable, which is very, very important. They should be non-toxic and non-inflammable also. Inflammable catch fire. They catch fire very easily, and non-toxic means they are not going to be very highly smelling. The freon group of refrigerants are, this is a good question, friends. They are hollow carbon refrigerants. That means chlorofluorocarbons. There will be carbon atom, fluorine atom, then chlorine atom. 1 ton of refrigeration is, it is a refrigerating effect to freeze 1 ton of water, that means 1000 kg of water at 0 degrees centigrade into ice at 0 degrees in 24 hours. 1000 kg of water to 1 ton is equal to 1000 kg, right? 1000 kg of ice, but it should be done in 24 hours. So what is the latent heat of cooling here? So approximately 80 calories, friends. 80 calories. That means 80 into 4.18 kilojoules, let us say. Okay, kilocalories. If it is in kilocalories, it will be kilojoules. If it is in calories, it will be in joules. Approximately 330 around, something like that. Okay, right. The correct answer is C. The power per ton of refrigeration is, just now I told you, it is 3.5 by COP. 3.5 by COP. 3.5 is the 1 ton of refrigeration in kilowatts. 3.5 kilowatts or 210 kilojoules per hour, minute, or 12,600 kilojoules, kilojoules per hour, or 3.5 kilowatts or 210 kilojoule per minute. All of them are equal to 1 ton of refrigeration. Okay, so as we know, COP is equal to your what you call Q by W. Okay, so W he is asking power, so W is equal to Q by COP. Okay, so Q is equal to, we know, 3.5 kilowatts, that is the ton or amount of cooling of refrigeration. An important characteristic of absorption system of refrigeration is they are quite in operation. Why? There is no compressor at all in vapor absorption systems of the refrigeration systems. There is no compressor. The compressor role is played by what you call absorber, then some generators, like that. There are 2-3 elements are there. Okay, right. That's why they are quite in operation. The evaporator used in household refrigerator is frosting evaporator. Frosting evaporator. Chaperon equation is in relation between Clapeyron equation, friends. Actually, temperature, pressure, and specific volume and enthalpy. It is not Chaperon, it is Clapeyron. Clausius-Clapeyron equation. It is, to be specific, it is Clausius-Clapeyron equation. So this is basically a relationship between temperature, pressure, specific volume and enthalpy. This is a good question, friends. All are involved: temperature, pressure, specific volume and enthalpy. If the evaporator temperature of a plant is lowered, keeping the condenser temperature constant, the HP of the compressor required will be, how it will be? It will be more. What he is saying? So it is like this, okay? The HP of compressor will be, right. This is the lowest temperature, this is the highest temperature, condenser and your evaporator here, friends. So your plant will be working between these two pressures, condenser pressure and evaporator pressure, P-condenser, P-evaporator. So he is saying that if the evaporator temperature of the plant is lowered, keeping the condenser, so this is lowering, okay. So what he is saying is this is lowered, for example, this is lowered, okay. So let us draw once again, this is earlier and it is lowered. So this gap is more, right? So you need more HP. In vapor compression cycle, the condition of refrigerant is saturated liquid where? After passing through the condenser. So it will be like this, right? So here, this is the condenser. So this is a liquid line, this is vapor line, okay. Evaporator, compressor, condenser and expansion valve. This is your TS diagram, right? So here, after the condenser, after being cooled, so it will be totally saturated liquid, saturated vapor. In between, it is wet vapor, okay, dryness fraction, something like that, 0.9, etc., okay. Right. In vapor compression cycle, the condition of refrigerant is high pressure saturated liquid when? Before entering the expansion valve. It is similar to after passing to the condenser. After the condenser means, so exit of condenser is the entry to the what you call expansion valve. Both are same. In a vapor compression system, the condition of refrigerant is dry saturated vapor before entering the compressor. Okay, let us say, for example, if it is like this, right? So let me draw it once again, friends. So this is, right? So this is liquid, this is vapor, okay. So here, so dry saturated vapor, this is after evaporator, or it is nothing but the beginning of the compressor, evaporator ending, compressor beginning, compressor ending, evaporator beginning, like this, okay. So before entering the compressor or after leaving the evaporator, it will be totally vapor, condition of the refrigerant. In a vapor compression cycle, the condition of refrigerant is dry saturated vapor when? Before entering the compressor. Right, just now I have shown you. The refrigerant used in small tonnage commercial machines, hermetically sealed units is, this is a good question, friends. This is sulfur dioxide. It is also a refrigerant, but for use for small tonnage commercial machines, hermetically sealed units. The refrigeration effect in dry evaporator compared to flooded evaporator in similar plant is, it is less. highest pressure encountered in a refrigeration system should be, this is a good question, friends, much below critical pressure, much below critical pressure, much below the critical pressure. Okay, friends. So, what is the critical pressure, by the way? For example, if this is your TS diagram, okay, this is your TS diagram, right? For example, for a pure substance, this is your critical pressure, where the latent heat is, this is your latent heat, right? It is going to decrease. So at some this point, it is becoming 0, right? So it could be applied for even refrigerants also. So how it should be? This should be, it should be much below the critical pressure. Much below the critical pressure. Otherwise, what will happen? It will, refrigerant will directly convert from vapor to liquid without taking any latent heat. That means there is no need of any condenser.
I need answers.
In a vapor compression system, and it is very difficult to design also, friends. In that case, in a vapor compression system, the condition of refrigerant before passing through the condenser is superheated vapor. Just now I have drawn you. Just now I have drawn you, friends. Superheated vapor. So this is your superheated. This is superheated state. Okay, friends. This is dry saturated state. So before entering into this is your condenser, right? So it will be dry superheated state. If this is wet, it will be saturated. Dry saturated vapor. If your initial point in the compressor is wet compression, then it will be dry saturated. If it is dry saturated in the compression beginning, it will be superheated state. Which of the following cycles uses air as the refrigerant? Bell-Coleman cycle. It is also reverse Brayton cycle, friends. It is also called a reverse Brayton cycle. It is used in refrigeration or air conditioning of the aircrafts, cooling in the aircrafts, inside the cabin, inside the place where the passengers sit. The heat rejection factor is given by, it is 1 minus COP. 1 minus COP. Sorry, friends. 1 plus 1 by COP. 1 plus 1 plus 1 by COP.
I need answers.
1 plus 1 by COP.
இந்த புண்ணியம் பாவம் இது எதுலயும் எனக்கு நம்பிக்கை இல்ல.
This is a good question, friends. Remember that in a spray washing system, if the temperature of water is higher than the dry bulb temperature of entering air, then the air is, how it is, heated and humidified. In a refrigerating mission, the heat rejected is dash. In a refrigerating mission, the heat rejected is less than. We have to check it, friends. It should be more actually, right? But he is saying yes, greater than, correct, greater than, because W plus Q is equal to heat absorbed is equal to heat rejected. So definitely it should be more. During sensible heating of air, dash decreases. Relative humidity. Wet bulb temperature is going to increase. It increases. This is going to decrease. Relative humidity. What is relative humidity? Water content in the air at the existing temperature by the water content in the air in the saturated state. Right. Because the sensible heating, it is nowhere related with the specific humidity or dry bulb temperature, because it is heating dry bulb temperature. Okay, so definitely relative humidity is the correct answer. sensible heating, dry bulb temperature remains constant, friends. Okay, this is constant. Late humidity only decreases. Wet bulb temperature not to consider. Specific humidity also not to consider. Specific humidity, okay, it is going to, this is temperature. Specific humidity is also going to be constant. So temperature increases, T1, T2. So T2 is greater than T1. And here you have specific humidity. This is going to be remaining constant. During humidification process, dash increases. Relative humidity increases. Humidification means something relating with the humidity. They should be increasing. The boiling point of dash is 10.5 degrees centigrade. Sulfur dioxide, ammonia, carbon dioxide are 12. They will be having more, friends. Sulfur dioxide is 10.5 degrees. Pick up the correct statement about giving up of heat from one medium to another in ammonia absorption system. Which is the correct answer? Weak solution to strong solution. Weak solution to strong solution. What? Heat will be given up from weak solution to strong solution. An infinite parallel plates with emissives E1 and E2, the interchange factor for radiation from surface 1 to surface 2 is E1 E2 by E1 plus E2 minus E1 E2. This is the effective emissivity is equal to E1 E2 by E1 plus E2 minus E1 E2. This is called also effective emissivity. The situation is like this, okay. There are two plates, they are exchanging emissivity 1, emissivity 2, they are exchanging heat, okay, like this. So between these two plates, let us say temperature T1, this is temperature T2, for example E2. So he is asking about the effective emissivity. That is a formula. 1 ton of refrigeration machine means that it is just changed the units of the, this is 1, okay. Earlier it was given 3.5 kilowatts, here it is given as 210 kilojoules per minute. Kilowatts means kilojoule per second. Okay, 1 second is called 60 per second, per minute it will be 60 seconds, multiplied by 60 seconds. So 210 kilojoules per minute, either 3.5 kilowatts or 210 kilojoules per minute or 12,600 kilojoules per hour. Remaining description is same. That is, it is the heat rejected or heat absorbed when ice melts. It is the when heat rejected when ice melts from and 0 at 0 degrees centigrade in 24 hours. That is 1 day. Okay, that is the standard here. The refrigerating effect is equal to 210 kilojoules per minute. When the air is passed through an insulated chamber having space of water maintained a temperature higher than the dew point temperature of entering air but lower than its dry bulb temperature, then the air is said to be cooled and humidified. Cooled and humidified. So dew point temperature is less than the dry bulb temperature. It is of course says cooling. Higher than them. So water maintains temperature higher temperature than the dew point temperature. The unit of thermal diffusivity meter square per hour or meter square per second also. Meter square per second or hour. Meter square per hour. Time units can be seconds or hours or even minutes also. But meter per second square, this is your acceleration. So don't confuse between thermal diffusivity units and acceleration units. And also one more parameter is having the same units. What is that? Kinematic viscosity. Kinematic viscosity is also dynamic viscosity by density. So it will be also having the similar units, meter square per second or hour or minute. Ammonia is Ammonia is highly toxic and inflammable. Highly toxic and inflammable. These are the properties not required by any refrigerant, friends, but it has got certain specific properties which will help in refrigeration. That's why ammonia is also used in certain refrigeration systems as a refrigerant, but it is highly toxic and inflammable. So the equipment which is containing this ammonia as the refrigerant, for example pipes, they should be very closely monitored for any leakages. Otherwise there will be fire accidents, and there will be other dangers also, right? Some toxic gases, vapors will be releasing into the atmosphere, and the workers will be affected, or the personnel who are managing that plant, they will be affected if they inhale those vapors. When the lower temperature of a refrigerating machine is fixed, then the quotient of performance can be improved by, what is this? D. Lowering the higher temperature. Lowering the higher temperature. So he is saying that COP is equal to, friends, T2 by T1 minus T2. So okay, T2 is the lowest temperature, T1 is the highest temperature. So he is saying this is fixed. Okay, so how to improve? So definitely you have to, what should you do? So you should lowering the higher temperature. So if T1 is reduced, this difference will be decreased and COP will increased. The evaporator changes the low pressure liquid refrigerant from expansion valve into low pressure vapor refrigerant. Evaporator changes the low pressure liquid refrigerant from expansion valve into low pressure vapor refrigerant. So pressure is not going to change, friends, because in the evaporator it will be constant. So in the evaporator the temperature will be pressure will be constant, uh, uh, but what will happen, pressure will be so decreasing from the condenser pressure to evaporator pressure in the evaporator, right? Right, it is like this, right? This evaporator, this is condenser. So pressure condenser, pressure evaporator. So there is a fall of pressure from P condenser to P evaporator. So low pressure vapor refrigerant, okay, low pressure vapor refrigerant. So after taking the latent heat Q absorbed, so it will be converting into vapor, right? But pressure is very low. The quotient of performance is the ratio of the refrigerating effect to the all of the above. All of the above will give heat of compression, work done by compressor, enthalpy increase in compressor. They are the different names for the same energy effect. Heat, work done, enthalpy increase, both are same. All are the energy are the synonyms for the for energy in the form of heat, work and enthalpy. All those are energy forms. Yes or no? Heat, work and enthalpy. In a refrigerator, liquid receiver is required between condenser and flow controlling device. If quantity of refrigerant for the system is, what is that? B, more than or equal to 3.65 kg. This is a good question, friends. Remember this. Pressure of water vapor is given by, this is a good question, friends. The questions are from air conditioning. This is C. PV vapor pressure, PD, PB and PD. Barometric pressure and vapor pressure. Okay, friends. So he is asking pressure of water vapor is given by, pressure of water vapor is given by, he is saying none of the above. Right. Let us not worry about this. This is a question from refrigeration. He is saying that none of the above. So he has given the answer also, right? So this is your vapor. This is, I think, it is Clausius-Capron equation. Anyhow, we will verify it. In vapor compression cycle using NH3 ammonia as refrigerant, initial charge is filled at high pressure side close to receiver. High pressure side close to receiver. Once again, a good question. In a heat pump cycle operating between the condenser temperature 27, highest temperature, that means T1, and evaporator temperature minus 23, that is T1, then the Carnot COP will be six. Right, how? Let us see this one. T2, Q2, Q1. So this is T2. So we need to find out T1 by T1 minus T2. That is equal to 300 by 50. Difference in temperature 6. 27 minus of minus 23 is 50. 300 by 50, that is 6. Had it been refrigerator, it would have been 5. Less by 1. Less by 1. Vertical lines on pressure enthalpy chart show constant. This is a good question, friends. Total heat lines. Pressure enthalpy chart, pH chart. It is also called pH chart. How it will be? So your pH, I think, is pre-light. So it will be something like this, right? It's called pH chart. A vapor absorption refrigerator uses dash as a refrigerant. Aqua ammonia, that means mixture of water and ammonia, NH3 plus H2O combination. Neither water nor ammonia nor freon, but it is a combination of aqua and ammonia. Vapor absorption refrigerator. Freon will be used in vapor compression refrigerator, VCR and VAR. Okay, in VAR, the reference is aqua ammonia. Ammonia and water. Aqua means water. Which of the following statement is correct for ammonia as a refrigerant? All of these are correct answers as far as ammonia is concerned. Toxic to mucous members, very dangerous, requires large displacement per ton compared to fluorocarbons. That means we need more power. It reacts with copper and its alloys. All of these. In vapor compression refrigeration system, refrigerant occurs liquid between which two components? Expansion valve and evaporator. Expansion valve and evaporator. This is your TS diagram, friends. So, right. So, this is wet. This is right. So here, so it is going to be liquid here, right? Expansion valve and evaporator. After evaporator, it will be vapor. So after taking the heat, it will become vapor. Expansion valve and evaporator. Liquid, okay. Right. Between compressor and condenser, it will be existing as vapor. But liquid between expansion valve and evaporator. The total pressure exerted by the mixture of air and vapor is equal to the sum of the pressures of each constituent would exert if it occupied the same space by itself. This statement is called Dalton's law of partial pressures. This is a good question, friends. Dalton's law of partial pressures. It is similar for volume also. Dalton's law of some partial volumes are also there. So V total is equal to V1 plus V2 plus V3 of the different gases, and similarly P total is equal to P1 plus P2 plus P3, something like that, okay, of the different constituents of the mixture of gases, different gases mixtures. This is called Dalton's law of partial pressures. Partial volumes is given by some other name, friends. Scientist name is given for partial volumes. Please check that. Which of the following statement is wrong? D is wrong. None of them is wrong. That means all of them correct. The value of COP is always greater than 1. In a vapor compressed system, the condition of refrigerant before entering the compressor is dry saturated vapor. The space between saturated liquid line and saturated vapor line in a pressure enthalpy chart is wet vapor region. All of them are correct. Which of the following statement is wrong? Okay, let us see which of the following thing is wrong. The effect of undercooling of liquid refrigerant is to decrease the coefficient of performance. This is the wrong one. All others are right. Performance of vapor compression refrigerator varies considerably with both vaporizing and condensing temperatures. Of course, that means evaporative temperature and condensing temperatures. That is T1, T2 and T1 respectively. In vapor compression cycle, the useful part of the heat transfer is at the condenser. Yes. In ammonia hydrogen electrolux refrigerator, it is also called electrolux ammonia hydrogen, not ammonia and water. Ammonia and hydrogen refrigerator, it is also called electrolux refrigerator. No compressor, pump or fan is required. All this is a good observation, friends. Remember that. In SI units, the ton of refrigeration is equal to 210 kilojoules per minute or 3.5 kilowatts or 12,600 kilojoules per hour into 60, 210 kilojoules per minute. While designing the refrigeration system of an aircraft, the prime consideration is that, this is a good question, friends, mass of the refrigeration equipment should be low because it has to fly at very higher altitudes. So to take larger weights will be difficult. It will be a load on the aircraft. So our effort will be always to reduce the mass of the refrigeration equipment as low as possible. In aqua ammonia absorption refrigeration system, incomplete rectification leads to accumulation of water in where it is going to take place in condenser. This is a good question, friends. Very good question. Please remember that aqua ammonia, that means NH3 plus H2O refrigerant ammonia absorption system, aqua. So the incomplete rectification leads to accumulation of water in condenser. Actually, the condenser, water should not be what you call accumulated, but it is going to happen. So if there is a incomplete rectification in the condenser, air refrigeration operates on, this is your Brayton cycle. Actually, to be specific, friends, it should be reverse Brayton cycle. Okay, neither Carnot cycle nor reverse Carnot cycle nor Rankine cycle. This is used in steam power plant, thermal power plants. Reverse Carnot cycle is once again a refrigeration cycle. Carnot cycle is a what you call power production, power generating cycle. Brayton cycle, reverse Brayton cycle. Okay, friends. Joule cycle is used in gas turbines, used in aircraft systems. But reverse Brayton cycle is used in air conditioning or refrigeration of the aircraft systems. It is, to be specific, it should be a reverse Brayton cycle. But as it is not given, you can choose Brayton cycle as the answer. The COP of an absorption type refrigerator given by T1 temperature, working system receives heat, T2 temperature of cooling water, and T3 evaporative temperature. This is a good question, friends. Remember this. So what is the correct answer? It is B. It is B. T3 into T1 minus T2 by T1 into T2 minus T3. Remember this expression without fail. Critical temperature is the temperature above which A gas will never liquefy. A gas will never liquefy. So what is going to happen actually? So directly it will be totally in the vapor state only. Okay. So there is no question of critical temperature. So what is the critical temperature for water? 374 degrees centigrade, friends. 374 degrees centigrade for water. 374 degrees centigrade. And the critical pressure is 221.2 bar. Okay. Critical volume is 0.00 something 31 something like that. Okay. I don't remember correctly. So if this is a temperature above which a gas will never liquefy, this is a good question. The index which correlates the combined effects of air temperature, relative humidity, and air velocity on the human body is known as, this is a good question, friends, effective temperature. Effective temperature, TE. This is very useful in the air conditioning systems. Mean radiant temperature, dew point temperature, no. Effective temperature. Because we need actually air to be circulated over the body. Okay, in summer your sweat has to be removed and also your body has to be cooled also, right? Sweat means your water vapor. Okay, something like water only, right? So this is going to be, it will be involving all those things, right? Relative humidity, air velocity, and also temperature, air temperature. These all three are involved over here. This is called effective temperature. The mass of water vapor present in dash is called absolute humidity. It is 1 meter cube of dry air. This is a good question, friends. Not water, nor wet air, nor dry air. Dry air, 1 kg. So it is not related with mass. First of all, you should identify it is related with the volume and it should be dry air. So both are satisfied in the second bit or B. 1 meter cube of dry air. Refrigerator is called dash absorption system. This is a once again good question, friends. 3 fluids absorption system. 3 fluid absorption system. Electrolux, hydrogen and ammonia. Refrigerator. For unsaturated air, the dew point temperature is less than the wet bulb temperature. Dew point temperature is the least temperature, friends. Okay, right. So it is something like that. Between the dry bulb temperature, TD is greater than T wet is greater than T dew. This is the what you call constant between dry bulb temperature, wet bulb temperature, and dew point temperature. As relative humidity decreases, the dew point temperature will be lower than the wet bulb temperature. The wet bulb temperature at 100% relative humidity is equal to, it should be same as, because the relative humidity is 100%. At RH is equal to 100%, 1 dW is equal to TD. That means dBT is equal to WBT. dBT, dry bulb temperature, is equal to wet bulb temperature at 5, 100%. 5 is the relative humidity. In reverse Brayton cycle, the heat is absorbed by the air during where constant pressure expansion process. Constant pressure expansion process. How your reverse Brayton cycle will be like this, right? Right. This is your PV diagram, friends. Compression, heat rejection, expansion, heat addition or heat absorption. Okay. So here he is asking, heat is absorbed where? Here. That is your constant pressure expansion process. curve lines on a cyclomatic chart, relative humidity. Okay, friends. Wet bulb temperature. See, temperature lines are this. Okay, this something like that. Okay, so it will be like this. Okay, so like this, some chart will be something like this. Your cyclomatic chart will be like this. Okay, so these curved lines will be something like this. They will be like this, right? So phi, this is the relative humidity. Okay, curved lines, relative humidity. Neither the wet bulb temperature, nor dry bulb temperature, nor dew point temperature. Relative humidity lines are curved. The horizontal line, non-uniformly spaced lines on a cyclomatic chart, say dew point temperature. This is a good question, friends. Remember, the vertical and uniformly spaced lines on a cyclomatic chart indicate dry bulb temperatures. So like this, like this, like this. Horizontal, vertical and curved lines. So he is asking about this one. Okay, like this. Dry bulb temperature. The bank of tubes at the back of domestic refrigerator. This is a good question, friends. Mostly asked in many of the examinations. Condenser tubes. The COP of corner refrigerator in winter will be as compared to summer. What is this? It should be higher. Summer compared to winter, the COP of a corner refrigerator in winter will be as compared to COP in summer. So what is COP? T2 by T1 minus T2. T2 lowest temperature, T1 highest temperature, right? So in summer this will be more, in winter it will be less, hence the reason. Carbon dioxide is, what are the characteristics? All of these: colorless, odorless, non-flammable, and all of these are the characteristics. On the pressure enthalpy diagram, condensation de-superheating is represented by horizontal line because the process where takes place at constant pressure. Constant pressure. Pressure enthalpy diagram. It will be something like this, friends. This will be like this, okay? So the superheated state, this is saturated liquid, saturated vapor, and superheated state, okay? This is your pH diagram.
That doesn't really help in the decision.
So horizontal line, right? So constant pressure, it was taking place at constant pressure, horizontal line. The humidification process on cyclomatic chart is shown by humidification, vertical line. Humidification, dehumidification, humidification, dehumidification. But both are vertical. Here the W is increasing, specific humidity is increasing. Okay. So in dehumidification, specific humidity is decreasing. For better COP of refrigerator, the pressure range corresponding to temperature in evaporator and condenser must be small. Must be small.
He takes him to a magical river and immerses him in that river. And that river has magical powers which protect the body of the child.
Choose the correct statement. Which of these is correct answer? A refrigerant should have low latent heat? No. If operating temperature of system is low, then refrigerant with low boiling point should be used. Let us see. Pre-cooling and subcooling of refrigerant are same? No. Superheat and sensible heat of a refrigerant are same? No. So what is the correct answer? So this is the correct answer. If operating temperature of system is low, then refrigerant with the low boiling point should be used. Low boiling point should be used.
The vulnerable point of any project.
The COP of heat pump working on reversed Carnot cycle is 1.
investors are vulnerable to noise.
D.
Now, here we put noise as that information or data flow that is not helping the investor in
Right.
the decision making process.
So this is the efficiency.
So
T1
noise
minus T2 by
disturbs an investor
T1 is
rather
going to
than
give the
helping an
efficiency.
investor. And
You have to check
that
it actually,
leads to
friend.
bad
This is if
decision
you are taking this as the T1, this as the T2, and this is the power output, power input, Q added or Q rejected like this, right? So it should be T2 by T1 minus T2. But how he has taken, let us see, right? I think he has taken reverse
So
notation.
a lot of
That's why
investors
he has given
try to keep
that
a lot of
particular formula,
notifications
right?
and keep pinging on
Critical
their
pressure
phone,
of liquid is
lot of
pressure
channels that they keep subscribing to.
above which
But
liquid will
that
remain
doesn't really help in
liquid.
the decision making, nor is it
Above
more
which
so
liquid will remain
to handle that.
in liquid. So there is no question of any conversion from liquid to vapor. In a pressure enthalpy chart, the space of to the left of the saturated liquid line
Greek
represents
mythology, the king
subcooled region.
and
Subcooled region.
this beautiful
There are two things, friends:
lady who was going
subcooling
to
and
burn
superheating.
everything.
Okay, left
They are
is going
left
to
with
be
a
subcooled
bright
region.
line.
Right to
The
the
prophecy
vapor
is
region
that
is
this
going to be
line will become the greatest
superheated region.
warrior of all
Left
time.
of the saturated
But
liquid
the
region
entire
will be
story doesn't
subcooled.
matter.
Right of the
So Thetis,
dry
who
saturated
Thetis is the
region
daughter of
will
the
be
Greek god,
superheated regions.
to protect her son, she takes him to a magical river and immerses him in that river. And that river
Okay,
has
friends.
magical powers
In
which
this video,
protect
we have seen
the
100
body
questions
of the
from
child.
your refrigeration and air
Because
condition
Thetis was
RAC.
holding the child
So
for
if
the
you solve
healing,
this question 100 questions, definitely I
she just
hope
gave
you will be
the
able to
child into
solve
the
all
water.
the 4
The
questions,
heel did not
which will
touch
be
the
are
water.
2 questions at least, which
So
will be appearing
after
from this
he had
particular topic RAC. Let us
body
meet in the next
dissolved,
video with another yet another
after
very
the
important topic
Trojan War
from your
where
examination point of view
won
TS
the war for
AE
the
GENCO.
Greeks,
Let us meet very
King
shortly.
Paris of Troy shot Achilles on the heel with a poisonous